Okay, this is the last video that you have to, or I guess get to watch before I come back. So I hope you guys are having a good week. I can't wait to see you whenever I get back. So for 6.5, we're talking about transformations and inequalities. And so we learned how to graph the parent function, graph their transformations, and we also learned how to solve inequalities, but we haven't done that graphically yet. So we're going to kind of join or connect the two. Like, how could we solve by graphing versus just solving it algebraically? So we're able to look at a graph and know how to solve as well. And I think it's really cool to see it graphically, because you may get an answer, but you're like, what does that actually mean? So I want us to be able to look at it both ways or from both angles. Just gives you more options of how to solve a question or maybe understand the background of it. So we have y equals absolute value of x minus 2 minus 1. And we're going to actually solve this inequality by the following steps. We're going to solve it graphically. So we're going to draw the horizontal line at y equals 1 first. So the horizontal line at y equals 1 right here. This is kind of like our above, below. This is our horizontal line. Then I'm going to graph the left-hand side. So the transformations, it starts at 0, 0, goes right 2, down 1. So it starts at 0, 0, right 2, down 1. Got a slope of 1 in both directions. Then the question says, what part of the absolute value graph is below? Because in my question, erasing this, my question, it says less than, so that means below the horizontal line. Give the answer in interval notation. So it has 2 points in which it touches the line, right? So it touches at x equals 0, and then it also touches at x equals 4. And it's below from 0 to 4. We're going to put it in parentheses, okay? Because that's when it's actually below. It's touching it. So if I put this, that would mean that it's touching it. But we say less than, not less than or equal to. If it said less than or equal to, then I would put brackets. But in this case, it just says less than, so I keep the parentheses. You might even want to add that in. That means it's parentheses because it's asking, or it's less than, not less than or equal to. All right, here's another one. We have a parabola, and it says that we want it to be greater than or equal to 5. So I'm going to graph the line at y equals 5. Then I'm going to graph the parabola on the left-hand side. So I start at 0, 0. I'm going to go to the left 1 and up 3. Then my slope is 2. So I'm going to go up 2 over 1, up 2 over 1. Draw my parabola. And the problem says, I'm going to erase this, the problem says greater than or equal to, so that means that it's going to be above. It also means that I'm going to have brackets. And it also means that I'm going to have 2 sets of parentheses, because if it's above, I've got this side, then I take a break because it's above in 2 places. It's above to the left of -2, and then it's above to the right of 0. and these are x values. So 0, -2. But then between -2 and 0, it's below. So I'm going to have to write it as two intervals. So all the way to the left, like it's extending, I would say parentheses, -∞, comma, -2, bracket, union, because it takes a break. Then it starts over again at bracket 0 to +∞. Now, just to prove my point, I know you probably believe me, but if you're curious, I want you to try and solve these two equations algebraically, and I want you to compare your answers, and they should be the same. So we only have to do this one. We can just do this one. But I want you to solve it algebraically, and then I want you to compare it to the interval that we already got. So pause the video and try that really quickly. And by number 2, I meant try to solve number 1, because we haven't done the square roots or solving inequalities of those. So, but we have done solving the absolute value inequality. So try number 1, solving it algebraically, and see if you get the same answer. So here's how I solved it algebraically. You get x is less than 4 and greater than 0, which means that it is between 0 and 4. So 0, 4, if you're wanting to put it in interval notation. So like I said, just showing it both ways. Sometimes if you maybe want to check it algebraically to see that you're correct, or flip it around, check it graphically. Sometimes solving it graphically is actually easier. All right, let's move on to number 3. So here we have a parabola again, left-hand side, right-hand side. And we're going to do the same steps that we did before. So if I were to draw the horizontal line, I would draw it at y equals 3. So let's go ahead and do that. From there, I'm going to graph the parabola. The transformations, I'm going to start at 0, 0. It's going to go right 3, down 2. So I'm going to go right 3, down 2. That's not a parabola. I'm very sorry. It is cubic function. So right 3, down 2. No, it goes up 2. What am I doing? Hawaii brain. Right 3, up 2. Y'all are probably just laughing at me right now. Then I have a slope of 1. Nothing in front, so up 1 over 1 on each side. Curves, curves. Then I want to measure, so I'm looking at my inequality. I want to measure what part of the graph is below the horizontal line, and also what's below. And then I'm also going to use brackets because it's touching it, because it's less than or equal to. And so in a cubic, I know my picture kind of looks like it's going straight down, but it's still progressively going further and further to the left. So it's never just going straight down and then stops. It actually goes out to -∞ on the left. So it's going to go from -∞, then it stops at this point, and that is x equals 4, bracket. All right, I want you to try the next two on your own and then check your answer with mine. And I'm going to actually go through how to do it, but I do want you to try these on your own because, like I said, there's always value in you doing it on your own. If I were in class, I'd make you stop and do it on your own. Okay, number 4. We're going to plot the line y equals 1 first. And then we're going to graph the square root. So I've got, it's going to go left 5, down 3, And from here, I've got a slope of 4. So I'm going to go up 1, 2, 3, 4 over 1. And absolute value graphs kind of do that, remember, like a hill. And my question is greater than 1. So that means I'm looking for above. Gonna write that. And it's also going to be parentheses because it's just a greater than. So it touches it at -4 and everything to the right of that. So my interval would be parenthesis -4 to positive infinity. Looking at number 5, I'm going to plot the graph y equals 4. So I'm going to plot the line y equals 4. Do that first. Then I'm going to draw, what is this one called? A rational. This one was a square root. I'm sure you have them all memorized by now. So rational. And the way we do rationals, remember, you start at 0, 0, and that's where your asymptote is, like the center of your asymptotes. I'm going to go right 4, up 3. So go right 1, 2, 3, 4, up 3. And I'm going to draw my dashed lines on either side. And I'm going to put my dots on the diagonals. And it kind of looks like this. And it looks like this. So it's touching, getting close to touching, but never touching. And then I'm looking at, okay, so it is greater, or it is less than. So I want to look at below. So I'm going to highlight with my, let's see what color, my red highlighter, everything, and I want you to do the same. I want you to highlight everything that is below my purple line. Here, and all this. Now, I want you to think about what is the interval that is contained in my red highlighted lines. Well, if I'm reading it like a book from left to right, all the way to negative infinity, it is never, ever, ever, because of these dashed lines right here, it is never, ever, 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 ever going to go above it in the negative direction. So, negative infinity, it stops at this asymptote, which is x equals 4. Then it takes a break for a little while, and it is above. And then it starts up again, being below at x equals 5. And it keeps going forever in the right direction. So 5 to positive infinity. Now, I hope that, I know that this one was a little bit harder, so you probably had to watch the video for this one. But always starting with, like the steps are, and they're on number 1, steps are, plot your horizontal line, plot the left-hand side using your transformations, then highlight what's above or below, and try to create that interval using interval notation. For me, highlighting it sometimes is helpful, but for instance, something like this, you need to think, like, does it take a break? Your lines, especially in a rational, are always going to get dangerously close, but they don't touch. So in the x direction, this line right here, you can kind of see it, it goes all the way to 4, but it doesn't touch it. So that's why I can put 4 parenthesis, because it doesn't actually touch, but it gets very, very close. So we call it 4. Then it starts up again at 5, and then goes all the way to positive infinity. So I hope this helps. I will be back next class, so I can help you with any questions that you have on this homework. But I do want you to submit it on Canvas before class, just to make sure that you got it, and then we will go over it with any questions that you do have next class.